Alright, so we are starting the video on questions 3 and 4 for 2019. Now, a little warning here. I am in my kitchen and my birds are loud. So we're going to pray that they do not interrupt this video much. And if they do, I'm so sorry. We'll never do it again. Alright, so we are going to do 3. There you go. All right, looks like we got a graph here. So we got a graph that says the continuous function is defined on the closed interval. All right, so we are defined on the closed interval -6 to 5, but the figure above shows a portion of the graph consisting of 2 line segments and a quarter of the circle at the point 5, 3. So it may be defined from -6 to 5, but it's only showing us the graph from -2 to 5. So it's cutting off that interval from -6 to -2. And it is known that the point 3, 3 minus root 5 is on the graph. So it says right here, that point right here, because this is the graph of f, it says on f the point 3, 3 minus root 5. So it told us that this point right here, it's not quite 1. So I'm assuming that that'll probably come in handy a little bit later. Okay. So it says in part A, if -6 to 5, so -6 being somewhere over here, if -6 all the way to 5 is equal to 7, then find the value of -6 to -2, so that piece that's not on the graph, and show the work that leads to your answer. Okay, well this is just some simple ideas with derivatives. I know that -6 to 5 of f of x dx, I know that that whole thing is going to be equal to, if I break it apart, remember like a to b is equal to a to c plus c to b. I can say that this is the same thing as -6 to -2, which is the piece I'm trying to solve for. And then I can add it to -2 to 5 of f of x dx. Wouldn't you agree that each of these pieces is going to add up to this whole here, right? So all I did was just break it apart at -2, because I know from the problem that this whole quantity is equal to 7. I'm solving for this quantity here, so I'm trying to get this quantity by itself, figure out what it is, right? And then to figure out this piece here, -2 to 5, that's just the area underneath the curve from -2 to +5. So as we find that area, let's figure it out. Like I know that like this area here and this area here are going to cancel each other out. So that cancels each other out right there. And I know that this area here and this area cancels each other out. So all this and all this are gone. So I'm trying to find the area. I need to find the area of this square, this triangle, and underneath this quarter circle here. So that one square is an area of 1. That triangle is 1 times 2 divided by 2 is 1. And then the semicircle is going to be this entire square minus the semicircle. So that square is a 3 by 3, so that's 9. And then minus the semicircle, which is a quarter of pi r squared. So that's going to be a quarter of 3 squared pi, or 9 pi. Okay. So then we just solve for this quantity right here, right? So I got that 7 equals the integration -6 to -2 of f of x dx plus, and that simplifies down to the 11 minus 9 pi over 4. Okay, and then just solving for this quantity here, I'm going to subtract 11 and add 9 pi over 4, so we get that -6 to -2 of f of x dx equals 9 pi over 4 minus 4. And that's what we get for the final answer. All right, so part A wasn't too terrible. It was just kind of finding the area underneath the curve and just knowing how to set it up. All right. All right, so let's go on to B. B says evaluate from 3 to 5. So here's 3, here's 5. Evaluate 2 times f prime of x plus 4. Okay. Now you can integrate this all as one quantity, but I found that the easiest way to do it is to break this apart. So we can actually like break up this quantity and say that it's 2 times the quantity 3 to 5 of f prime of x dx plus the integral 3 to 5 of 4 dx. So doing each of those pieces, I think makes it just a tad bit easier of a quantity to look at, but it's up to you. All right, so if I integrate this piece here, that's just the integral of f prime. What's the integral of f prime? Just f, right? So this is 2 f of x evaluated from 3 to 5, and this is 4x evaluated from 3 to 5. So this becomes 2 times the quantity f of 5 minus f of 3 plus 4 times 5 minus 4 times 3. Okay. Now, f of 5 and f of 3, well, we're given the graph of f. F of 5 is just simply 0. So I'm going to finish it up here at the top. That's going to be 2 times 0 minus, and then f of 3, see this is the whole point that they gave this in the beginning of the problem. F of 3 you can't see in the graph, but it tells you that it's 3 minus root 5. And then plus that quantity is 20 minus 12 is 8. Okay. So if you solve this out, you can distribute the 2. Looks like it's going to be negative 6 plus 2 root 5 plus 8, which simplifies down to 2 plus 2 root 5. So that's the answer to B, which, again, that wasn't too terrible. I don't think that was the worst problem in the world. All right. And then C. C says to find the absolute maximum. Okay, so of G. Now G is a new equation we're introducing. G is the integral from negative 2 as our starting point to x of f of t dt. And we want to find that absolute maximum value on the interval negative 2 to 5. So to justify that answer, we're going to say that this occurs, so max occurs, so absolute max occurs at a critical point of G, or an endpoint. Okay. So let's start with finding the critical point. So in order to do the critical point, we need to have G prime, right? So G prime of x is equal to the derivative of this integral. And by FTC part 1, we know that that's just simply going to be f of x. And I'm going to go ahead and state that. By FTC part 1. Anytime you take the derivative of an integral, I would always state by FTC part 1. A lot of times they don't count for that anymore, but sometimes they do, so you just want to be careful. Okay. All right, so then we need to set f of x equal to 0, right? So f of x equal to 0. And so all I got to do is simply find those points on the graph, and that happens at negative 1, it happens here at 1/2, and here at 5. So that's x equals negative 1, comma, 1/2, and 5. 5 just happens to be an endpoint. And then really the only other justification we need is just to test those points and see which one's the maximum. All right, so we got 0 is one endpoint, we got negative 1, 1/2, and 5 is the last endpoint. So I know if I plug 0 into that, oh wait, 0 wasn't the other endpoint. I don't know why I said 0. The other endpoint was negative 2. I apologize. So if I plug negative 2 into this integral here, that's the area from negative 2 to negative 2, which is 0. If I plug negative 1 into that, that's just this area right here, which is positive 1/2. It's just the area of that triangle. If I go all the way here to positive 1/2, these areas cancel, and the area of this little tiny triangle right here is actually going to end up being negative 1/4. You can do, it's 1 times 1/2 divided by 2. That's negative because it's below the x-axis. And then lastly, all the way from negative 2 to 5, we actually figured that out in part A. It was 9 pi over 4 minus 4 was the, wait, no, I'm sorry. It was 11 minus 9 pi over 4, right? This area right here was 11 pi minus 4. 11 minus 9 pi over 4. So I know this is 11 minus 9 pi over 4. which is, let's see, 9 pi, so that's 9, that's like a little bit more than 18, it's like 19 divided by 4 is going to be like 4 point something. Anyway, I don't really know because this isn't Calc active. This is like 6 point something, 5 point something, I'm not exactly sure. But the point is it's bigger than the other 3 points, so my absolute maximum value on this curve is 11 minus 9 pi over 4, and it occurs at time equals 5. So you want to classify that, hey, this is my absolute max. All right, cool. And then lastly, D. D says find the limit as x approaches 1 of this crazy mess right here. Now, 9 times out of 10, it's going to be L'Hopital's rule. Anytime you see a limit just randomly thrown into some problem like this, a lot of times it's L'Hopital's. So just to be sure, you always want to plug the number in. So I'm going to say this is equal to, I'm going to plug 1 in for x. So this is 10 to the first minus 3 times f prime of 1 over f of 1 minus arc tan of 1. And a lot of times that's end up being 0 over 0 or some issue, but let's just see what we get. So that's going to be 10 minus 3 times f prime of 1. So this is the graph of f. F prime of 1 is the slope at 1, which if you do rise over run there is just 1, 2, 3. It's 4 over 2 or just 2. So that's the slope of that line. And then divided by f of 1 is just simply the value at this point, which is f of 1 is 1 minus, and the arc tan of 1 is, well, if you know some trig, is pi over 4. Okay, you got to think what the tan of what gives you 1, and that's pi over 4. And it looks like it's not 0 over 0, so we actually just have an answer here. It's just going to be 4 on top and 1 minus pi over 4 on bottom. So a lot of times D is the hardest problem on here, but this ended up being actually one of the easiest ones, so that worked out. Here's the answer key. We get a point in part A for knowing to set up this quantity right here. We get a point for, let's see, a point for finding the piece by the area underneath the curve, and then a point for the answer. In part B, we get a point for using the fundamental theorem of calculus, which was simply just integrating. Like you can even see, we integrated each of these pieces right here, and then plugged in 5 and plugged in 3. And we get a point for the answer. C, we get a point for recognizing that g prime of x is equal to f of x. We said by FTC part 1, but they didn't grade for that. We identified -1 as a candidate, which was one of the points we actually excluded, so it's just a random point to get. And then a point for justification in our answer, the point that we got 5 as our answer, or 11 minus 9 pi over 4. And then D was simply just a point for getting the answer. No L'Hopital is required. All right, so that was question 3. Let's move on to question 4. So question 4, I apologize, I hear something in the background. I think everything's okay, sorry. Okay. All right, so we got this, says a cylindrical barrel with a diameter of 2 feet contains collected rainwater, as shown in the figure above. So we got a constant radius here. And the water drains out through a valve not shown, so at the bottom of the barrel, so there's probably some little valve here, water's draining. The rate of change of the height of the barrel with respect to time t is modeled by blah. And you can see that the rate is negative because the height is constantly decreasing, right? Where h is measured in feet and t is measured in seconds. And the volume of the cylinder with radius r is given. So they gave you the volume of the cylinder, which we don't think we needed to be given, but anyway. A says find the rate of change of the volume. So A is asking for dV over dt. Of the water in the barrel with respect to time t when the height is 4. So h is equal to 4. So all we really need now, and we know what dH over dt is, so we're good there. All we need is to take the derivative of the volume. So in this case, volume is pi times r squared times h. And the only thing I would take a note of is since we're not dealing with anything with radius, and because it's a constant, you can go ahead and say that volume is pi 2 squared h. Or I'm sorry, that's the diameter. The radius is just 1. So in this case, our volume is just equal to pi h. So dv over dt is going to be the derivative of pi h, which is pi dh over dt, or pi times -1/10 square root of h. And it wants to know what the rate of change of the volume is at time equals 4. So if I plug 4 into that, I get pi times -1/10 square root of 4, which is equal to negative pi over fifths. And this is, we're talking about the volume changing, so this is going to be feet cubed per second. Does it say? Yeah, per second. Okay. All right, and that's it. That's how we do that one. No issues there. Let's move on to B. B says when the height of water is 3, okay, so when h is equal to 3, birds be quiet. When the height equals 3, the rate of change of the height of the water with respect to time is the rate of change. So is the rate of change of the height. So is dh over dt, is that function or is that value increasing or decreasing? And explain your reasoning. Okay, so it wants to know is the rate of change increasing or decreasing? So it wants to know is that dh over dt increasing or decreasing? How we tell if that value is increasing or decreasing is to look at the derivative of it. Right? So it wants to know, is this increasing or decreasing? Is that value getting, is it going to be increasing or decreasing? So we need to actually take the derivative of this and plug in 3 and see what we get. Okay? So d2h over dt squared is equal to, the derivative of this, if you think of this as -1/10 h to the 1/2, you can say this is -1/20 h to the -1/2. Or, and then since we're taking the derivative with respect to time, that's going to be times dh over dt. It's implicit differentiation. But remember, we got to plug back in dh over dt. So this is -1/20 square root of h, if I brought that to the bottom. And then times dh over dt, which was -1/10 root h. Okay. So that's my second derivative, and if you notice, I got a root h on top and a root h on bottom, and those cancel out. So I'm left with positive 1/200. So what that's saying is, no matter what my height is, my second derivative is always positive. It's always concave up. It's always greater than 0. So I'm gonna say that. So I'm gonna say since d2 dt squared is greater than 0, for all of h greater than 0, so no matter what the height is, I have a positive derivative there, then the rate of change, which is dh over dt, I know that the rate of change is increasing at time equals, height equals 3. All right, so all we did for B was just look at the derivative of what it was asking for, and see if it was positive or negative. Since it's positive, I know that it means it's increasing. Okay. And then lastly, C says at time equals 0 seconds, the height of the water is 5, and we're going to use separation of variables to find an expression for h in terms of t. So separation of variables, it wants me to figure out what h equals given its derivative. So I know that dh over dt is equal to -1/10 square root of h. If I separate the variables, I can bring the square root of h to the other side, and I can say we got 1/root h dh is equal to -1/10 dt. So we separated the variables. We got the h's on the left and the t's on the right, and we're going to integrate each of those pieces. So I'm going to integrate that, integrate that. Okay. The integration of 1/h, you can think of that as h to the -1/2, is going to be 2 h to the positive 1/2, right? We add 1 to the negative power to get 1/2 and divide to get the 2 right there. And the integration of -1/10 is -1/10t and then plus c. Okay? So now the next step is to solve for C, and we're going to use the fact that time equals 0 seconds. The height of the water is 5. So I'm going to plug 0 in for T, and I'm going to plug 5 in for H. So it's going to be 2 root 5. So C is root 5, or 2 root 5. So then I got 2h to the 1/2 equals negative 1 over 10 T plus 2 root 5. And all I have to do is now is just divide by 2. So if I divide by 2, h is going to equal, divide by 2, negative 1/10 divided by 2 is negative 1/20 T. 2 root 5 divided by 2 is just going to be root 5. And then I also have to square it to get rid of the 1/2 power. So there is my expression for h, doing separation of variables. So that does it for 3 and 4. I think both those questions were pretty doable. You should be very thankful you were given a cylinder there and not a cone, because we had a constant radius, which simplified things down a little bit. But let's look at the answer key. So we get a point for taking the correct derivative, okay, and a point for the answer. So we got negative pi over 5, which wasn't terrible. B, we get a point for taking the correct derivative. Okay, so that's the derivative. A point for making sure that we times it by dh over dt, and then a point with the explanation for the reason. That is going to be the fact that we know the second derivative is 1 over 200, and because that's greater than 0, the rate of change of the height is increasing as the height of the water is 3 feet. Okay, and then 4 points for the very end, which I think that's some gimme points for part C, but it's that you get 1 point for separation of variables, so doing this point right here. 1 point for the correct antiderivatives, constant of integration, so solving for that, and then 1 point for h of t, so getting h by itself. And if you didn't do any separation of variables, you get 0 points, and you only get half the points if you don't solve for C. Okay. I think that's my shortest video yet. Questions 3 through 4, I think it was not too terrible. And then we will finish up questions 5 and 6 tomorrow. And again, if my birds were loud in this video, I'm sorry. Getting on my nerves. Going crazy. Okay, if you have any questions, message me. I will talk to y'all tomorrow.